All right, folks, we are on page 25. The last thing we have to do is writing the equations of our graph. I believe we started this in almost all of our classes. We're going to finish it now, okay? The other thing is I'm going to be working with page 21 here, so kind of have both at the ready. All right, so I'm going to do the two examples that are up here to begin, and then I'll do two more on the bottom. First thing is recognize what kind of graph you're dealing with. Okay, if we look at our directions, it says write the equation of the square root or cube root function represented by each graph. So we have to recognize that because this is the curvy one that stops, that means we are dealing with the square root graph. Okay, so I know right away, square root. Second thing I need to look at is my vertex. So there's my vertex. You need to get me there from my origin. And that's literally just count out where am I moving, write it down. So I can see I went down 2. I also went left, 1, 2, 3, 4, left 4. Okay. I also need to look at, is there a reflection? There is not. This graph is opening the same direction as our parent function is, so there is no reflection there. If you forget what a reflection looks like, look on the back wall as it is still up there. Okay, so let's start writing the equation. Leave yourself some space here after the equal sign. If I'm going left 4, that means I have plus 4 inside my square root. If I'm going down 2, that means I have minus 2 on the outside. And that's what we did for our warm-up on both Wednesday and Thursday. Okay, so the next thing we have to look at is that a value. And in order to look at the a value, this is where we're going to go back to page 21. We are going to compare the pattern of our graph. So you're going to look at this pattern, and you're hopefully going to remember it, or say, hey, that looks familiar. And the pattern is, where are we moving? Okay, so what changes on this is I'm going to go up 1 and right 1. All right, if I go up 2, my graph is supposed to go right 4. And if I go up 3, any guesses? Any guesses? Right 9 is what it did. And hopefully you're saying like, wow, that looks really familiar. And you're absolutely right, because we did it with parabolas. Okay, that's the same pattern that a parabola did, it's just we're moving up and to the right. Okay, this is ultimately what we are going to use to find us our a value. So let's first start out by looking at my vertex and counting to a nice point. Well, in order for me to go right 1 unit, I actually had to go up 2. I went up 2 before I ever went right. So then we got to think about it. What did I multiply by 1 to make it actually go up 2? And the answer here is 2, which means this graph vertically expanded by 2, and therefore that is my a value. Okay? And that's all it is. Now, let's try another one. Next one, we should recognize, hey, that's Sven. That's our cube root looking guy. So now I don't have a vertex, instead I have a point of inflection, but we said our point of inflection was kind of that center balancy point. So if I look here, the point I'm looking for is this guy right here. Okay, so we're going to do the same thing. Get me from my vertex, get me from the origin to my vertex. And in order to do that on this one, I'm going right 3 and up 2. You don't have to write it. I think the writing helps. Again, we are doing a cube root function, so let's write that down. Okay, let's think about a reflection. Does my graph look like this? No. My graph has flipped. I'm now going down instead of going up. Well, that's what a reflection is. So this guy does have a reflection. Okay. So let's write what we got so far. Y equals negative, leave some space, cube root. If I'm going right 3, I need a minus 3. If I'm going up 2, I need a plus 2. Okay. Now for the a value. Just like our last one, we're going to look at a pattern. All right, for on this one, I can go either direction. I can go up 1 and right 1, or I could go down 1 and left 1. If I go up 2, I am going right 8. If I go down 2, I'm going left 8. Okay, so again, the pattern for a square root is 1, 1, 2, 4, 3, 9. For a cube root, it's 1, 1 in both directions, and then it's 2, 8 in both directions. Okay, let's see what's happening on our graph on page 25. When I went down 1, I went left 1. Or maybe you chose to go up 1, that's fine. If you go up 1, I still went left 1. I think I said left here, I meant right. Either way, it's following the pattern. If it follows the pattern, that simply means your A value is 1. That means nothing changed. So we don't need to write anything here. If you wanted to put a 1, that is fine. You don't have to, though. Okay. We need to do one. I'm actually going to do 2 more examples. So for number 1, I already kind of went ahead, and I wrote in the fact that we went right 1, we went down 5, and this graph did reflect, because again, if we compare it back to the original, my graph's going the other direction now. So that got a reflection here. All right, now here's the dilemma on this problem. When I go to look at the pattern, when I went down 1, I did not go right 1, I went right 4. Okay. The problem there is I don't know how my X values got changed. I don't know how my A values got changed. On this one I could see, because I could clearly see I counted up 2 units to go right 1, which is my first number in the pattern. Okay. I can't tell where I went right 1. Right 1, it looks like it's somewhere in here. Well, I can't tell how far that is. Sorry, it was a little low. It looks like it's somewhere in here. Moral of the story. There's a compression taking place here. Since we cannot see where right 1 hits the graph, I got to go back up here and I'm going to follow the directions for that second bullet point. And what that says is we are going to pick another point on our graph, not our vertex, and we're going to just plug it into our equation and solve for A. Okay. So sadly, there's no quick way to do this, not in a video at least. So let's take this point here, and let's figure out what is that point. That point is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 5, negative 6. And remember, that is an X value. That is a Y value. I can plug them in and ultimately solve for A. Okay, so plug in your Y value. X we said was 5, and now we're just doing math. Okay, I know 5 minus 1 is 4. I know the square root of 4 is 2. So this turns into negative 2A. And now I'm just solving like normal. Add my 5 over. Negative 5 plus 1. I'm sorry, negative 6 plus 5 is negative 1. And then if I divide by negative 2, negative 1 divided by 2 is positive 1/2. Okay? So that means my equation is now y equals negative 1/2 root x minus 1 minus 5. Those are the hardest ones. There's not a ton of them, but that's how we do it. Okay? All right, last one we're going to do together, and then it's your time to practice. First thing, that's a Sven graph. We're dealing with a cube root. My point of inflection is right there. Where did I go? I went left. 1, 2, 3, 4. I went down. 1, 2, 3, 4. And once again, you guys, my graph flipped. So since my graph flipped, I got a reflection. Okay. I have negative, leave space, cube root. X, left 4 would be a plus 4, down 4 would be a minus 4. And if we look at that pattern, when I go up 1, 2, 3, I went left 1. So, guess what that means? That means my graph vertically expanded by 3. Put a 3 there and you're done. Okay. So you are always trying to get 1 unit to the right and determine what your height is. That height ultimately is what tells you your A value. Alrighty, go ahead, try the 2 on page 26. I'm going to put the answers here. And when you're done, move on to your test review. There you have it.